Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at how to simplify expressions involving roots. So let's go ahead and begin. So, as you are probably familiar with, when you're dealing with roots, you're dealing with something often involving radicals. So let me give you what it looks like. This is your radical. This inside the radical is called the radicand, and then this guy right here is called the index. Now, if n equals 2, you normally don't put the index number there. But if n equals anything else, you put it there. So 3, 4, 5, 6, whatever, etc. Now, what we're trying to learn here is how to simplify things. So what I want to do is I want to start by giving you an example or two, and then I will try to show you the principle after that. So imagine you have the following. Let's say you have with an index of 4, you have 2 to the 4th power. So how do we simplify that? What does it become? Well, the first thing is that you deal with the stuff inside the radical. You deal with the radicand with that exponent right there, 2 to the 4th power. So to work that out, 2 times 2 times 2 times 2. 2 times 2 is going to be 4. 4 times 2 is going to be 8. 8 times 2 is going to be 16. So what we have now is we still have the 4 as the index, and we have 16 here. Now, the question that we're asking here is as follows. What is the 4th root of 16? In other words, what number can I multiply by itself 4 times to get the number of 16? And you can see our answer is right here. The answer is 2. So if we had to simplify this all the way to the end, you will see that the answer is 2. But we have to be careful here. It's not just any kind of 2. It has to be absolute value 2. It has to be a positive 2. Because when you start dealing with negatives, you start getting into things called imaginary numbers, which is something we will talk about in the future. But the point to make right now for all of you who are watching this is that basically that when the index and the exponent under the next to the radicand, if they're the same, they basically destroy each other, and you're left with the radicand itself as a number. And so this is kind of why we got this here. And I worked through the math right here for you so you can see that. So when you have 2 to the 4th power, with the radical with the 4th index, you're just going to get the 2 again. That's the point here. Now, what about when we're working with negative numbers? Again, it's the same process, but I want to walk you through it again another time here. So we have 3, and then we got negative 5 here, raised to the 3rd power. So going through the same math, what we're going to do first? We're going to deal with this guy right here. Negative 5 times negative 5 is 25. Times negative 5 is going to be negative 125. That's what we got. So if we had to rework this, we got negative 125 to the 3rd power, like so. I'm sorry, with an index, to the 3rd index. And so the question we're asking ourselves here is that, what is the 3rd power? The 3rd root. Excuse me, the 3rd root of negative 125. In other words, what number can I multiply by itself 3 times to get negative 125? And so again, the answer is going to be negative 5, like we just did. And so you can see here we still have the negative. So I don't think I need the parentheses. Let me just put it like this. Yeah, like so. And so that's kind of how that works. Now, something else that I wanted to show you is that when you're dealing with power properties of exponents. So take a look at this. You guys already know. I'm going to start with, let me go back for a second and give you the final principle here. I forgot to mention that. So here's the final principle here. When you're dealing with even roots, if you will, even and not odd. So by even I mean they don't have a negative sign or whatever. The principle is as follows, and then I'll move back to what I was going to talk about. When you have the nth index raised to the a to the nth power, you're going to get the absolute value of a. And then of course, when you have for odd, it's the same idea, but you don't have the absolute value sign. Oh, excuse me, you don't have that. That's kind of what's happening there. So if it's even, you're going to get the absolute value, but if it's odd, it's going to be like this. And basically what they mean by even and odd, I believe, is that even is like it's a positive number, odd is that it's a negative number. So that's for like the final result, if you will. Okay. So let's move back to what I wanted to talk about, which is the power property of exponents. So you're familiar with this from prior videos. Let me go ahead and recap this for you. So what's happening here is that when you have a n raised to the second power, it's the same thing as doing a to n, because you multiply these two together right here. So to give you an example here, let's take a look at this one. You have y to the 12th power, all right? And we want to simplify this. Now remember, if we don't put the index, the index is probably going to be 2. So just for the sake of completion, we'll put the 2 right here. Got the 2 right here. And so basically, if we could find a way to have a 2 here on the inside, the two 2's, I hope that doesn't confuse you, will destroy each other and we'll have our final answer. So to do that, this is what we're going to do. We're going to rework it so that it's y to the 6 to the 12th power, like to the 2, like that. And so why am I doing that? Because by having this 2 out here, they will destroy, the two 2's will destroy each other. This 2 will destroy this 2, and we're left with our final answer down here, which is going to be y to the 6, like so. That's why we did that. And if I had to give you one more example, let me show you another one. So let's say this time I have y to the y to the 14th, like so. Again, I can make it more complicated. How about y to the 15th, and then I have an index of 3 here. Oh, let me make that a little bit bigger for you. 3. And so what do I do here? Well, it's not too complicated. I still have my 3 on the outside, and then here I have y to the 5, and on the outside I want a 3. Now, why did I do that? Because 5 times 3 will give me my original value of 15. And so this 3 and this 3 destroy each other, and I'm left with my answer of y to the 5th power, like so. Okay, so moving to our final example here, this is kind of a tool in simplification here. Okay, so imagine you have the following: 25 x squared y squared, like so. Okay, now here's what's happening. Notice how the exponents are even. So that means that our answer for those have to be absolute values. When the exponents are even, they have to be absolute. When they're odd, it could be either or. That's what I was trying to say back here about 5 minutes ago. So, in other words, when the exponent is even, you have to make sure you have absolute values around the radicand answer. When the exponents are odd, you do not need the absolute values. That's what I hope that's clear now. So, here we go. Now again, notice how there's no index. And so when there's no index, we know that it's 2. That's kind of a given. So in other words, we're looking for the second root of 25. In other words, what number do we multiply by itself, twice, 1 times 1 or 2 times 2, whatever it is, to get 25. Okay, now for the x squared and the y squared, we already know that, hey, there's a 2 here, there's a 2 here. These guys eat each other, they destroy each other. And so essentially we got to figure out, well, what's the square root of 25? So we know that's going to be 5. And then we know inside our absolute values, we're going to have x and y. Why is that? Because remember, when the exponent is an even value, it has to be an absolute value when you simplify it. And so since 2 is an even number, we have to make sure that we have the absolute value here. And so this is the answer. So in this video, we did several things. So let me see if I can back up and make things clear here. So we learned how to simplify expressions that have roots inside them. And so we started with the basic example. Basically down here, the principle is as follows. When you have the nth index raised to the nth power, basically if n is even, then the radicand here will have to have the absolute value signs around it. If n is odd, you don't need the absolute values around the radicand. So essentially what happens is that when you have the same number and the index, and also as the raised power, if you will, they eat each other, they destroy each other, and you're just left with the radicand. And what I mean by radicand is that this guy right here, whatever value he is, that's kind of what happens a lot of times. Actually, every single time. And so again, I walk you through actually solving it step by step, and then I showed you the shortcut at the end. Now after that, I gave you an example where this time the exponent was an odd number. And so because it's odd, we don't it doesn't really matter. We don't need the absolute value sign. That's why it can still be -5. Then after that, we took a look at the power property of exponents. And now this is a valuable tool because if you can rearrange an expression with roots where the exponent, the power, and the index are the same, you can simplify it quickly. And so essentially what we did here was that we had y to the 12, square rooted, and we were able to change this so that it was y to the 6 raised to the second power. The twos ate each other, and we were able to get our answer. And then we did a second example here. And then lastly, and in this particular slide right here, what we did was that we had to just simplify it. And so we already had the twos and twos here, but see, notice how they were even. This is why we had to do the absolute value signs around the x and the y. But for the 25, you just get the square root of 25, which is 5, and that's how we got that answer. So I hope that this video was useful for you and that you were able to understand and to appreciate the things we talked about and how you can use various techniques we've learned in prior videos to try to simplify expressions that involve roots. So my name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.